Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, sketch the function and the function is y equals 2x over x squared minus 25. And this is a rational function. So the first step is to find the discontinuities in this function. Now in this function, there is no common factor in the numerator and the denominator. That means this function has no poles. Now we can find the vertical asymptotes in the function. The vertical asymptotes exist at x values that make the denominator equal to 0. So we can set the denominator expression equal to 0 and solve for x. So we can add 25 to both sides. So we get, now we can apply square root to both sides. So we get x equals plus minus. So this function has two vertical asymptotes. X equals negative 5 and x equals 5. Now we can find the horizontal asymptote in this function. So for that, we'll have to divide each term in this function by x raised to the degree of the denominator. Now in this expression, the degree of the denominator is 2. That means we should divide each term in this expression by x squared. So we get y equals 2x over x squared over x squared over x squared minus 25 over x squared. Now we can simplify this expression. So we get y equals 2 over x over, now x squared over x squared is equal to 1 minus 25 over x squared. Now we can evaluate the limit x approaches infinity for this expression to get the horizontal asymptote. So we do limit x approaches infinity, so 2 over x over 1 minus 25 over x squared. Now we can apply the limit. So we get 2 over infinity over 1 minus 25 over infinity squared. Now we know that 1 over infinity is 0, so that will make the numerator equal to 0, and in the denominator 25 over infinity square becomes 0, so the overall value is 0 over 1, which is equal to 0. That means the horizontal asymptote in this function is y equals 0. Now we can find the direction from which the curve approaches this horizontal asymptote on the left and right side of the x-axis. So for that, we can evaluate the limit x approaches a big positive number and a big negative number. So we can start with the left side. So we get limit x approaches negative 100. So we can use the expression 2x over x squared minus 20. Now we can evaluate the limit. So we apply the limit, so 2 times negative 100 over 100 squared minus 25. So it's negative 100. Now in the numerator, we get a negative value. And in the denominator, negative 100 square will be positive 10,000 and minus 25 will be a positive value. So we'll get a positive value in the denominator and the overall value will be negative. That means on the left side, the curve will approach the horizontal asymptote from below. So curve approaches from below. Because the negative value that we get will be less than the zero at which the horizontal asymptote exists. Now we can evaluate the limit on the right side. So limit x approaches positive 100. So the given expression, so 2x over x squared minus 25. Now we can apply the limit. So we get 2 times 100 over 100 squared minus 25. So we get a positive value in the numerator and we get a positive value in the denominator. So the overall value will be positive. That means the curve will approach the horizontal asymptote from above because any positive value will be greater than the zero at which the horizontal asymptote exists. So we can conclude, so curve approaches from above. So we are done with the analysis for the asymptotes. Now we can find the intercepts. So let's start with the x-intercept. So for x-intercepts, we should sub in y as 0 and solve for x. So we can cross multiply the denominator. So 0 times x squared minus 25 is equal to 0. Now we can divide both sides by 2. So the 2's on the right side get cancelled out. So we get x equals 0. So the x-intercept is 0, 0. Now we can find the y-intercept. And for y-intercept, we should sub in x as 0 in the given equation. Now we can simplify this expression. So we get numerator becomes 0. So and in the denominator we get negative 25. So we get 0. So the y-intercept is 0, 0. So this function has one x-intercept and one y-intercept. Now we can do the analysis for critical points, and for that we'll have to find the derivative of the given function. Now this function is a rational function, it's in the form of a fraction, so we can use quotient rule to find its derivative. As per the quotient rule, so we start with the derivative of the numerator, and the numerator is 2x, so its derivative will be just 2 times the denominator minus the numerator expression, then times the derivative of the denominator, and the derivative of x squared will be 2x, and derivative of 25 is 0 because 25 is a constant, divided by the square of the denominator. Now we can simplify the numerator expression. So in the numerator, if we distribute 2 into the parentheses, we get 2x squared minus 50. And then in the next part, 2x minus 0 is just 2x. So negative 2x times 2x is negative 4x squared over x squared and 5 squared. Now we can simplify the numerator. So 2x squared minus 4x squared is negative 2x squared minus 50 over x squared minus 25 squared. Now we can factor out a negative 2 in the numerator. So we get y prime equals negative 2 x squared plus 25 over x squared minus 25 squared. So this is the expression for y prime. Now we can find the critical numbers at which the y prime is equal to 0 or undefined. So we can start with y prime equals 0. So we can sub in the left side as 0. So negative 2 and then x squared plus 25 over x squared minus 25 squared. So we can cross multiply the denominator. So we get 0 equals negative 2 times x squared plus 5. Now we can divide both sides by negative 2. So the negative 2 on the right side will get cancelled out. So we get 0 equals x squared plus 25. Now we can subtract 5 from both sides. So the 25's on the right side get cancelled out. So we get negative 25 equals x squared. And now we can apply square root to both sides. Now the square root of a negative number is not a real number. So that's why there are no critical numbers for which y prime is equal to 0. So that's our conclusion for this part. So no critical numbers. For y prime equals 0. Now we can find the critical numbers for which y prime becomes undefined. And we got a fraction for y prime. So this fraction will become undefined if the x values make the denominator equal to 0. So we'll sub in the denominator of y prime equal to 0 and solve for x. So we get x squared minus 25 equals 0. Now we can add 25 to both sides. 25 is on the left side get cancelled out. So we get x squared equals 25. And now we can apply square root to both sides. So we get x equals plus minus 5. So these are the vertical asymptotes that we got early in our analysis. So these are the critical numbers for which y prime is undefined. Now we can find whether the function is increasing or decreasing on both sides of these critical numbers. So we can use the number line method. So we can show these critical numbers 5 and 5. So we can use a test value on both sides of these critical numbers. So for negative 5 on the left side, we can use negative 6. On the right side of negative 5, we can use negative 4. And for 5, we can use 4 on the left side and 6 on its right side. So we'll sub in these test values one by one in the first derivative expression. So if the y prime is greater than 0, that means the function is increasing in that interval. And if the y prime is less than 0, that means the function is decreasing in that interval. So let's start with the left side of -5. So we can use this equation for y prime. So y prime, so we get -2 and then -6 squared plus 25 over -6 squared minus 5, then square. Now in the numerator, -6 squared plus 25 will give us a positive value, and times -2 will give us a negative value. And in the denominator, the result will be positive for all x values because there is a square on the expression. So the overall value we'll get is negative in this case. That means the function is decreasing on the left side of this vertical asymptote at x equals -5. Now we can do the analysis on the right side. So we'll sub in x as -4. So -2 times -4 squared plus 25 over -4 squared plus 25 squared. So in this case, the expression in the parentheses in the numerator will be a positive value times the negative value will give us a negative value in the numerator, because -2 times a positive value will give us a negative result, and we'll get a positive result in the denominator, so the overall value will be negative. That means the function is decreasing on the right side of -5. Now we can do the analysis for the other critical number. So we can sub in x as 4, so -2 and then 4 squared plus 25 over, so 4 squared plus 25 and then square. So again we'll get a negative result in the numerator because 4 squared plus 25 will give us a positive result, times -2 will be a negative, and denominator is positive, so the result is negative. That means the function is decreasing on the left side of critical number x equals 5. Now we can do the analysis for the right side of x equals 5. So we can use the test value 6. So again we'll get a negative result in the numerator, positive in the denominator, so the overall value will be negative. That means the function is decreasing on the right side of critical number x equals 5. Now we can do the point of inflection analysis by finding the second derivative of this function, but that will be a very complicated expression. And since we have done all the analysis up to the critical point, we can sketch the function. So we can start by showing the vertical asymptotes. So the vertical asymptotes are at 5 and -5. So let's assume 5 is here and then -5 is here. Vertical asymptotes. And now we can show the horizontal asymptote at y equals 0. Now the intercepts, and we got 0, 0. Now we can use the increasing, decreasing results we got. Now on the left side of this vertical asymptote, the function is decreasing. So that means we can show the behavior around the vertical asymptote like this. And now for the horizontal asymptote, we got that on the left side, the curve approaches the horizontal asymptote from below, so like this. And on the right side, the curve approaches from above, so like this. So on the left side, the curve will look something like this. Now on the right side of the vertical asymptote x equals -5, the function is decreasing, so the behavior around the asymptote, vertical asymptote, will be like this. Now at the vertical asymptote x equals 5, on the left side the function is decreasing, so the behavior around that asymptote will be like this. And since the x and y intercepts are at the origin, the curve can be shown like this. Now on the right side of x equals 5, the function is decreasing, so we can extend the curve like this to join the other part around the horizontal asymptote. So this can be the sketch of the function. So I'll just make it more curvy like this. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.